Okay, in this lecture video, we're going to talk about Lewis dot structures for modeling ionic bonding. So this is going to be a two-dimensional model of how atoms, or in this case cations and anions, are interacting with one another so that we can show it on paper. And we know that in ionic bonding, we're talking about the interaction or the attraction between a positively charged cation and a negatively charged anion. So we're going to look again at how to show that with Lewis dot structures, and then we're going to practice it a lot in class. So the example that we're going to look at is the ionic compound sodium chloride, and we're going to look first at the cation. So we know that in sodium chloride, NaCl, our cation is going to be sodium. And we know that in this particular compound, we don't have a sodium atom, we have a sodium cation. Now we could show that with a Lewis dot model. So we know that you start with the sodium atom, and if you look on the periodic table, you'll see that the valence shell electrons for sodium are 3s1. So that means if I want to show my electron on this sodium, I could just show one electron, because there's one electron in the valence shell. Then we know that to form the sodium cation, I'm going to lose one electron because that will empty out energy level 3. So it's no longer half filled, or in this case, just one electron in it. And so now when I lose that one electron, I can write the dot model for the sodium cation, which looks like this. At the same time, I can look at chlorine, the chlorine atom, which we know is going to gain an electron to become the chloride anion. And if I want to write that using Lewis dot models, first I can look on the periodic table to see what the valence shell is. And if I do that, I'll see that chlorine is a 3s2 3p5, so valence level energy level 3. And I'm going to a total of 7 valence electrons to put on my picture. So 1, 2, 3, 4, 5, 6, 7. And we know that that chlorine atom, when it forms its anion, is going to gain 1 electron. And we know that there's an empty spot where that 1 electron can go. It's right there. And since we're in energy level 3 and all there is are S and P subshells, we want a total of 8 electrons to fill that subshell. So that 1 electron will accomplish that. So my final Lewis dot structure or dot model for the chloride anion looks like this. So then if we want to think about how this works with the cation anion together, the way we can think of it is that the cation, which is sodium, or the sodium atom, I should say, before this has actually formed the cation. And if we bring together the chlorine atom, 6, 7, this electron, let's change colors so that it's a little bit more clear. This electron right here is going to be given from the sodium atom to the chlorine. So then we can show the Lewis dot structure for this particular compound looks like this. So when you draw the Lewis dot model for ionic compounds, you pretty much just draw the Lewis dot model for the cation and the anion, and you show them next to each other with their respective charges. So we'll practice that some more in class.